This is great for decision making, right? So all the wonderful sessions we've heard throughout the days, and even just through this session in general, there's so much decision making that needs to happen, whether it's like Elise with decision making for traverse planning, right? Or what scenarios are you wanting to have with your field astronauts? That's all to say that there's so much decision making that needs to happen. And sometimes that can get either lost in the weeds or you're trying to rush to make a decision. And then how do you organize it? And so, what I'm going to chat about today is what our team is working on with a support framework and try to get a sense of how to organize decision making for, in this case, lunar exploration. And you'll see on the bottom right there our radish mascot there. So, but yes, please, next slide. So the thing about decision making support frameworks, don't know if the slide is actually going to advance or not. I guess the slides are also deciding whether to advance. There we go. So where to even go, right? It's not just location, but then what do you want to do? What kind of science do you want to do? What objectives, which would mean what kind of instruments are you wanting to go for as well? So you could do minerals, elements, volatiles as well. And then those all have their own subcategories, right? So metal oxides versus creep terrains and different radioactive materials. And then it's not just water ice with the lunar poles, it's also carbon-bearing species. Where are those at? How deep are they? Next slide, please. So in that case, it's still going about not only just location, like as I was saying, just what kind of missions are you wanting to look at as well. And so we're having just a smattering of just CLIPS missions. And what are they going to do? What are they going to teach us? Next slide, please. And then as we're trying to focus on the lunar South Pole, as well. There's all these different sites. Next slide, please. Of just where to even go. So traverse planning, narrowing down just these Artemis 3 candidate landing sites. It takes a while. It takes communities to communicate with each other. And it's not just science, it's also technical feasibility, it's the seasons, it's illumination. And that's all environmental decision making, and that's fantastic. Next slide, please. But there's more to it, and so there's a lot of not just future forward looking, but also lessons learned as well. What's worked with Apollo? How do we now presently know about hazards? So dust in that case. What happened during Apollo that we can learn about now? So I believe earlier this morning, if you were in the dust and regolith session, you've probably heard a lot about the technologies involving electrodynamic systems and how to repel dust off of equipment or how to make sure that our equipment is going to handle dusty environments. And then, so yeah, tech showcases and also private sectors coming in as well. It's going to increase. What kind of interactions are we wanting to have here? So it's not just an environmental, natural decision-making framework, but now we got to be aware of hazards on not just the natural side, but also anthropogenic hazard side, and then federal, international, private entities coming into. So now there's got to be a social conduct to happen in the field as well. Next slide, please. So in that case, where there's decisions, there's uncertainties as well. So this could be environmental variations, abundance levels of your volatiles. You get there and you may not realize how abundant that particular mineral is. What are you going to do? And yeah, it's a lesson learned. Good job. You now have figured out whether can you continue on a certain path or do you need to pivot? Or even just controllability. How do you deal with interference as well. So is there another private entity nearby that is also conducting operations? How do you make sure you don't interfere with them? Or even just within your own suite of instruments and make sure they don't interfere with each other either. That's a decision-making process. What can be turned on? What can stay on for how long? What do you hope to achieve? So again, and this may all sound like, yes, Caitlin, okay, that's a lot of decisions, get on with it. Next slide, please. So we have the RAD framework here. So this is resist, accept, direct framework. So this has been going on since 2015 with the National Park Services and the USGS. So my team has brought on one of the leading USGS folks working on RAD for Earth. And now we're having some interesting feedback and conversations with National Park Services crews that are using this framework on a terrestrial level. But our team is then kind of translating that into how do we deal with this for lunar exploration? Next slide, please. And you might be wondering what resist, accept, direct might be. I like using the boat analogy here. So resist would be you're in a storm, you want to fight the winds, you want to use your motor, you're gonna hardcore attempt to just head back home that you've already started away from. So you're just kind of tackling and fighting prevailing winds. Accept would be just accept the flow. It's down with the sails, go with the wind and see where it takes you, hopefully somewhere safe. And then direct is that you will use the winds, use the sails, and steer to a safe and new destination. Next slide, please. So for lunar exploration, resist would be, in the sense, like restoring, preservation, so anything that holds a historical or heritage significance, which is a whole level of decision making all in its own. Accept would be maybe limiting the number of vehicles within a given area to reduce interference. And then direct would be, okay, we want to establish more permanent bases or more permanent outpost structures as waypoints or as safety areas, but you are directly influencing the environment for even if it's a semi-permanent area or even a launch pad, that is a direct decision to enhance the environment for something else. Next slide, please. So that's not to say that every one of these is bad. In any case, this is what makes RAD interesting. It's adaptable. It's because it's taking past and current decisions and data to essentially just keep adapting the decision here. So one decision route is not a one size fits all. That's not the case whatsoever, but it allows you to adapt and pivot in case you need to do that based on whether it's management decision, maybe your objectives have changed, or the resources are not what they seem to be. Maybe the technology isn't quite there yet. And what do you do? Next slide, please. So, and again, this might also turn into like, well, what if this and what if that? We can go into what if scenarios all day long, and I hope that's not what the Q&A is going to end up being. But this is certainly not supposed to be a trial and error approach. That's going to be very costly. It's going to be very timely, very time consuming if that comes to that realization. So the adaptiveness is you got to monitor the situation. You got to recognize the uncertainties going in. And that's what we're trying to hone in here for, basically to get teams ready to understand, yeah, you're going to have uncertainties, but do you yourself understand the uncertainties to then pivot if needs be? Next slide, please.
And you're down to your final minute.
Thank you. Yes. Okay, go ahead and skip the slide real quick then. Yeah, we'll oops, okay, yep, just keep clicking through. Yep, excellent, thank you. Whoops, Go back a slide. Thank you. Right. Okay. So we'll just leave it on this slide then. So this is where that adaptiveness comes in. It's not linear, where you got your goals and objectives. What kind of activities do you need to get the objectives done? And then your functionality. And while linear as that may be, if something happens in the middle, you're stuck. And so RAD helps with various scenarios. It can go with forward planning. And so this is what we're already doing for Earth systems, for Earth ecosystems on regional scale levels and also very small scales as well. And so how we're able to do that for Moon and also Mars as well is very exciting. So what my team is doing is taking different user case scenarios, which I don't have time to go into at the time, but keep an eye out because we're wanting to use the next few months to create a user manual per se of just like, okay, this is how decision making can work with exploration. And then we're going to hopefully publish some case scenarios using RAD pretty soon. So exciting work. So thank you all so much.